Okay, so we're going to work on rationalizing expressions, which is essentially functions that have roots to them. Okay, they've given us a few rules. Essentially, if we're trying to rationalize, and usually we want to rationalize the denominator, we would multiply the original number, the top and the bottom, by that root denominator. Okay, which makes the top root AB over a rational number. Okay. We'll get into an example of that, and then we'll come back to our second rule here. So our very first example here, we have 3 over 4 root 5. Okay. What we're going to do here is we're going to multiply both the top by root 5 and the bottom by root 5. Okay. Now, if you're unsure whether to multiply it by root 5 or 4 root 5, you can do both, because eventually you'll be able to simplify the other. Okay, so let's do it by root 5 first, which on top will leave us with 3 times root 5. And on the bottom, if you're not sure how to quite look at that, think of it like 4 times root 5 times root 5. And due to the associative property, we can just multiply the two root 5s by each other, and what will they become? They'll just become 5, exactly. So we'll be left with 4 multiplied by the value of 5. Okay? Which means, as a simplified version, we have 3 over root 5 divided by 20. Okay. Now, like I said before, if you were unsure what to do there, I just want to, as a side note here, so I'll move this other stuff over. Move it over. Actually, I'll bring it down. But just as a side note, say we weren't sure what to do there, and we thought that maybe we would have to multiply by 4 root 5, both sides. Let's go ahead and do that. 4 root 5. 4 root 5. This way we're safe. We know we're doing both. On top, we'll be left with 12 root 5. Okay. And again, think of this like 4 numbers being multiplied. 4 by root 5 by root 5. Well, we know the 2 root 5s will be 5, and 4 by 4 is 16. You'll then have 16 times 5. Anyone know what that is, top of their head?
80.
80? Amazing. Okay. So we have 80. 12 root 5, that's a 5, divided by 80. And if we simplified that, what would we get down to? If we divide this, let's say, by 4, we have 3 root 5 over 20. Okay, so if you're unsure on whether to keep the rational number, go ahead, keep it in there. You can just simplify after in the end. Okay? Example 2. Example 2, scroll up a little, deals with, I'm not sure if you guys recall, kind of the rule of difference of squares. So our denominator here has 2 root functions, but they're subtracted or added to each other. Okay, really depends. What we're going to do is we're going to multiply by the opposite operation, the exact same denominator. So our roots stay the same. We have root A and root B. The only difference is the operation between the roots will use the opposite one. Okay? And what that'll allow us to do, and it's obvious when it's 1 times these numbers, we'll get them on top, but essentially you have to distribute the 1 to both of those terms. Think of it like they're in brackets. What this does on the bottom is it allows just the numbers underneath the roots to become the values. And I want you to think of this, I'm not sure if you guys recall the idea of a difference of squares, when we have maybe x squared minus, let's say, the value of 9. This goes back to some factoring. If you guys remember, when factoring a difference of squares, we can root the first and the last term, and we'll get x plus 3 and x minus 3. All we're doing in this case is, say we're starting with the x minus 3, we're multiplying by the x plus 3 to give us a difference of squares in the end. Okay, so our value, or operation between, will always be that negative term. Okay, so we'll always have a negative term there when we go through it. So when we're going through these, let's bring this over. We want to rationalize our denominator here. So we're going to be multiplying by root 6 and root 3, but what's the operation in between going to be? Negative. That's right, we want to use the opposite operation. And whatever you do to the top of a fraction, you have to do to the bottom. Now, if you're kind of lost on how this is all going to work out, we know the answer from looking above is going to end up just being 6 minus 3. okay, which is essentially 3. But I'll walk you through all the distributive properties here. Essentially, think of these as brackets. Okay, all of these are brackets, and we're going to multiply all of them together. So let's combine them. Because when you multiply fractions, you do the top by the top and the bottom by the bottom. So you kind of have 2 times root 6 minus root 3 on top. And on the bottom, we have root 6 plus root 3 times root 6 minus root 3. Okay, so distributive property. On top, the 2 is just going to go in front, and here it's going to become a negative 2. Okay, so our next step down, the numerator is easy. We have 2 root 6 minus 2 root 3. The bottom becomes a little more difficult. Do you guys recall FOIL, distributive property, when you do the first terms by each other? Then we do inside terms, last terms. So that's last terms. And then outside terms. I've lost track of what I was doing here. Yeah, FOIL, right? You can always think of it, they also have a rainbow method. But the idea is you take the first term and you have to multiply it by both of the terms in the other bracket. So we take our root 6 times root 6, and what's that going to give us? Anyone know? 6, that's right, simple. Then we take that root 6 times negative root 3. It's going to give us negative root 3 root 6. That's right, it is just going to cancel. Then we do root 3 times root 6. We get positive root 3 root 6. And then finally, the last terms are root 3 times negative root 3 will give us negative 3. Okay? So if we look at our 2 terms in the middle here, we can simplify these. One is negative value, one's a positive value. They will cancel each other out. And on the bottom, we're left with our numerator still the same, 2 root 6 minus 2 root 3. The bottom of this now reads 6 subtract 3, which was 3, just like we had anticipated it to be. Okay? The only difference is we went through all of the math here. Okay. So we've rationalized the denominator in this case. And finally, our last question here. We're going to rationalize this denominator. Now this one's a little different from what we were looking at. It does have a value here. And what we're going to do is, like I said before, if we're unsure what to multiply by, just multiply by the entire denominator with a different value. So here we're going to multiply by 2 root 6 minus 3. Okay? 2 root 6 minus 3. So when we go through that, on top, we'll set it up like distributive property. 2 root 6 subtract 3. On the bottom here, what's going to happen? We're going to have another way to think of it if you're still unsure. Multiply the first term by the first term and the last term by the last term, and we'll just have a negative in between. The positive and negative will become the value in between. So 2 by 2 gives us 4, and root 6 times root 6 is a value of 6. And 3 by 3 gives us 9. Okay? We'll distribute the 5 on top. We get 10 root 6 minus 15 divided by 24 minus 9. We could factor a value out here on top. Or on the bottom, 24 minus 9, what's that going to give us here? 15. Great. We can actually factor out the value of 5 on top. Oh, I had that already on top. Actually, let's go back. Factor it back to this. I know that was pointless there. But the reason being is because now I can simplify. Right? This will now become 2 root 6 minus 3 over the value of 3. Okay? A little simpler this way to look at. And that is rationalizing expressions.